Could we build a mass transport vehicle that runs on a nearly limitless power source? If done right, it could solve so many problems faced by transport systems around the world: traffic, environmental impact, energy consumption, resource expenditure, cost. So what would this hypothetical perfect vehicle look like? First of all, it would need to have a sizable cargo capacity. It's not just us, after all, that rely on vehicles to get from point A to point B. So do our goods. Shipping is one of the invisible threads holding society together. A multitude of essential businesses such as groceries, pharmacies, and even banks rely on shipping companies to deliver goods to them. Second, it would need to be fast. What's the use of holding all that cargo if it's just going to end up spoiled by the time it reaches its destination? Lastly, it would need to be highly efficient. That means it would need to be cheap to operate and maintain. Otherwise, it would be an impractical option for most. This is also why a vehicle with a nearly infinite power source would be so appealing. This tech would cut out a significant chunk of the operational cost of this hypothetical vehicle. Fuel. Do you have a vehicle in mind yet? If you pictured a self-charging battery-powered train, you'd be right on the money. You'd also have the exact line of thinking Fortescue had when envisioning a way to significantly cut down the operational cost of their mining business. Their groundbreaking idea is just as we described: a self-charging battery-powered train. They even came up with an ambitious name for this new vehicle: the Infinity Train. With this, they could ferry iron ore from their mines at a minimal cost. This is thanks to gravity batteries, batteries that store up potential energy to be repurposed as electricity. That's the same tech that enables hydroelectric dams to generate power. It's also how roller coasters work. As the train goes downhill to deliver its cargo, this tech allows them to use the train's 34,000-ton weight, as well as the massive weight of its load, to produce the kinetic energy that would charge the power systems, which will be used on the train's return trip. Fortescue hopes to complete the development of the Infinity Train before 2030, which is the self-imposed deadline to eliminate their carbon footprint. While all this sounds great on paper, it might be decades before we see trains similar to the Infinity Train replace our existing freight and passenger train infrastructures. It may never even happen at all. While battery electric train systems are currently in use in countries such as Canada, Germany, and Japan, they're mostly used to enable electric trains to pass through areas with no electric ground rails or overhead catenary. They're electric trains first and foremost. With our current battery technology, the downsides of converting an entire fleet of electric trains in a city would outweigh the benefit of eliminating virtually all of a train system's environmental impact. For starters, a train powered by batteries alone would be far less reliable than a conventional electric train. Not only do batteries add another point of failure to the train, but they also degrade in capacity over time. So if the world were to switch from diesel to batteries for powering trains, the demand for batteries and the materials required to manufacture them would increase significantly. Even with their emission-free operation, these trains would still place additional pressure on our already dwindling supply of natural resources. Infinity Train may not be a practical replacement for our existing train systems, but it was never intended to be so in the first place. The Infinity Train represents Fortescue's desire to participate in the ongoing global initiative for companies such as Google, Apple, and Microsoft to go carbon neutral. Let's hope the public sector eventually catches up.